So yesterday we ended here, and we watched a little video about Sinbad and Cassette. So let me just talk you through that again in their little love story. So Sinbad, so if it's sign, notice they start with sign. So Sinbad is going to have Cassette sit up front with him. He's telling everybody that their signs are the same. And then he's going to have Cassette's sister sit in the back with his brother. Okay, that happens. And then so the sign of whether it's sum or difference, that's how those work out. But then Cassette's in charge. She asks him out on a date. She's really just using them, though. It's really not a nice thing. But since it's cosine, cosine's first. So Cassette says, I ain't sitting with Sinbad. My sister's going to sit up front with me. And I'm telling everybody, our signs are absolutely not the same. And then I'm going to make Sinbad sit in the back with his brother, right? Not such a bad way to remember them, really. I mean, it's cheesy, but sometimes the more cheesy, the better. Then we have the double angles. On the first day we did this, I showed you how to get the double angles from this sine and cosine here, which is still doable, but it's a lot of stuff that I'm thinking most of you probably wouldn't do in the end anyway. I think it's better sometimes just to know them, and we can try to connect them to Cassette and Sinbad a little bit, I guess. There's not really a story like this, but so if I have the sine of 2 alpha or 2 theta or 2x or whatever, but that's called my double angle. So then what Sinbad really wants is he really doesn't want to be just with, he really doesn't want to be on a double date with Cassette. He wants the two of them to just be alone. Sine alpha, cosine alpha, okay? No brothers and sisters with them. The two of them get to be together alone. That's what Sinbad wants. So that's your sign of a double angle. It also starts with sine because it's a sine thing, right? Then we have our cosine of a double angle. Cosine of 2 alpha. So Cassette's in charge again. She don't want to have nothing to do with Sinbad, okay? But she's tied up with him now. So this is cosine squared alpha. She wants to subtract Sinbad out of her life. So she will be the one and only, okay? Remember that it looks like Pythagorean identity, but it has the subtraction in it, okay? So Cassette wants to subtract Sinbad away and leave with 1, okay? Whatever you got to do to remember them, okay? I mean, because are you going to have to use every single one of these on the exam? Highly unlikely. But they are all fair game, and you don't know which one, so you still have to know them all, okay? We good? Remember all those I showed you the first day? Like, at least we don't have to know absolutely everything. That is a good thing. All right, so now grab the half sheet of yellow paper you picked up on the way in and your other 4 yellow papers. So the plan here, this little half sheet, this is going on ISN page J. You can just tape this down flat like this. So my thought is you tape this down, and then when you're ready to tape in the other pages, they can be folded on top like normal, but then here's your instructions. I took them off the top of all the pages so we'd have more room to write. And we talked through these yesterday, so we're not going to talk through them again today. Now, as I said to you yesterday when I passed out these yellow papers, I should have stapled them. It was almost like I was trying to make this as difficult as possible. Bless you. Because the way to identify them in the top right corner, you see how it's really, really light? And it says FRQ task models, and you can barely read it. That's how you know the differences, okay? So let's go through quickly and try and figure this out. So find A and B. A and B are front and back. So if you found A, you found B. And I can tell you that A, this is what it looks like if you can't tell. A and B, I think you can kind of read well. And then you actually write A and B on it so you can read it. Do you understand what I'm asking you to do? Yes, okay. And then if you can, anything else you can read, that's fine. But I'll click through and show you C in case you can't tell if it's C or D. I really did not intend for this to be this complicated. So here's C. C starts with G of X equals 2 arc cosine. So C and then D is on the back of that. I think G and H are the ones that are really hard to read. And then here's E. E has G of X equals the E's at the top. That's E. See, you ought to appreciate packets, wouldn't you? Instead of being like, oh my God, it's a packet. Maybe that's what I'm, bless you. And then this is G. Yeah. You check your neighbors. There's no O, yeah. It's got to be a C or a D. Like check the other side. And again, I apologize that it's just a hot mess. Okay. All right, but we're going to start with B. So find B. Start with B. We're going to skip around a little bit. Bye. Now, I'm going to preface this with, I was going to skip around in general, but B has a lot of good challenging ones on it. I'm working the challenging ones with you. Would it make any sense for me to work on the easy ones with you? No. So I don't want this to completely turn you off on FRQ4. Because remember, FRQ4, it's at the end. You're tired. Some of you about to have to inhale your food and go take an APPS test. And then also, it is a little bit more, it's the one that's going to push, that's meant to push you out of your comfort zone. Doesn't mean you don't have the skills. You all have 100% of those skills, okay, that you need for this. But it also, sometimes some of these can be a little challenging, and it's separating the men from the boys. It's also separating those of you that freak yourself out and those of you that can take a deep breath and go, I know what to do, and I'm going to do this, right? And just level-headed. That's coming from me, and I'm definitely, nobody would ever describe me as level-headed, I don't think. All right, so let's look at the first part here. We are going to rewrite g of x as a single log base 10 without negative exponents, and this is what our answer should look like in the end, okay? So as I write it down, I'm going to take care of the exponents. So this becomes log base 10 of x to the 1/2 power minus log base 10 of x to the 3rd power. Any questions about where any of that came from? That's pretty basic for our exponents, right? Okay, so I have 2 logs with the same base. It's going to become 1 single log with division. So in the numerator, I have x to the 1/2 power, and I have x cubed down here. Any questions? I feel like we should all be able to get to that point because we should know enough about logs. All right, but remember, this is FRQ4. We have to have everything simplified 100%. So I can't leave an x in the numerator and x in the denominator when I can reduce it. What I need to do is subtract the exponents, the bigger parts in the bottom, so it's going to stay down there. I'm going to change that 3 to 6/2. And then I'm going to take this 1/2, subtract it away from 6/2, so that leaves me with 5/2. So this gives me log base 10 of 1/x to the 5/2 power. So not just log properties, but exponent properties and fraction properties, and not freaking out and doing weird things, right? And I will tell you, as I worked through all 4 of these pages, after I did a couple of things, I was like, let me go check myself. I felt like after every single part, I needed to check myself, because that's not necessarily a weird, crazy answer, but it's not something we see all the time. Even some of the simple answers, I was like, that seems weird. And I'd be like, oh, I was right. So if you have that feeling, you might be right. I mean, it doesn't guarantee anything, but I'm just telling you, that's, again, kind of pushing you out of your comfort zone of you know, what makes sense. Any questions on that? Yes. Well, you could do square root of x times 5. Yes, I don't know where the 6 came from, but yes. If this is a 5/2 power, it'd have to be the square root of x to the 5th power. Yes, yeah, you can. Because it doesn't say it has to be with exponents. It just says that you can't have negative exponents. So it'll work. All right. So this next one. Rewrite h of x as an expression in which cosine appears once and no other trigonometric functions are involved. So when I look at this part right here, that's my double angle. And that's Sinbad, right? Remember, what Sinbad wants is the 2 of them, sine of alpha and cosine of alpha, to live together in harmony. Oh, I should be alpha, I'm sorry. I mean, that's what it is, or whatever. But this particular thing says x, so we need to actually use x. Sorry about that. Okay. Yes, because it's in terms of x. So yes, we have to actually use x. And then the denominator is sine of x. Okay. But then in this particular question, Cosette's dreams come true because Sinbad falls right out of that relationship, and you're left with 2 times the cosine of x. And do you see how simple that is if you know your identity? If you don't know your identity, it's impossible. But if you know it, it's crazy easy. So it does all of these that involve this stuff, they aren't necessarily going to be weird and crazy. Okay? What questions do you have? Anything? Okay. All right, so let's look at B1. Now we're solving, and it says j of x is equal to the square root of 10. So I'm going to write that down, 10 to the x times 10 to the third minus the square root of 10 equals the square root of 10. You got less than 15 minutes left to test, and your brain is tired. Do these square roots of 10 cancel each other out? No. But do you see how when you look up there that your brain sees a negative square root of 10 and a positive square root of 10? So even though you know they don't zero each other out, if you're not really focused, your brain can do things that you didn't intend, right? Just because of the way it sees it. So be very careful. So, but I am going to add that over there. Just like, I mean, if you do your steps, you're less likely to do that is when we start to try to skip things. So, well, when I do this, I have 2 things with the same base that I'm multiplying, so I'm going to add the exponents, right? So it's 10 to the x plus 3 equals, and then I'm going to add that square root of 10 over there. That's going to be 2 square roots of 10. Sorry, I'm still thinking about Anthony's question. Even though writing it as a root is correct, there's no need to do that, so don't do the extra stuff in case you accidentally put the numbers in the wrong place. Does that make sense? So it's not wrong, but like when there's not a need to do that, just, I don't want everybody doing that. Okay. All right. Now we're here. Now what I really need is I'm going to need to get this x plus 3 out of the exponent, so I'm going to need to take the log. Well, I also have something with a 10 over here. Now that's the square root of 10, but I can rewrite it as 10 to what power? No. What's the square root as a power? 1/2. So this is the same thing as 10 to the 1/2 power, right? So I'm going to divide both sides by 10 to the 1/2 power. So that leaves me with x, no, not x, 10 to the x plus 3 divided by 10 to the 1/2, and that's equal to 2. Everybody with me so far? On the left, I could reduce that just like I could on the other one, right? I'm going to need to take x plus 3 and subtract 1/2. So if I think of this as 6 over 2, this will give me 10 to the x plus 5/2 power, and that's equal to 2. So when I go to take this log to get x out of the exponent, I need to use the same base as the base of the exponential. Like that's a 2, but whatever, it is what it is. But the 10 is what matters here. So I'm going to take the common log of both sides. Now they're not telling me I have to write the 10, so I don't have to write the 10 as the base. You can if you want to, and that helps you. But now this gets to come out front, and log base 10 is 1, so I get x plus 5/2 equals the log of 2. And then I'm not going to do anything weird. This is log base 10 of 2. I can't do anything with it. Log base 2 of 8, I could, but there's no way to make that happen. So it just stays the log of 2, and that's fine. And then I just subtract that over there, so I get x equals log of 2 minus 5/2. Okay. What questions do you have? Anything? All right. So now I could have also here, I could have taken the log of both sides here, but I still have to recognize my exponent. I'd have to split them correctly and do everything else. And I think some of us would have maybe split that weird there. This is just what made more sense to me. But there is more than one way to attack it. What questions do you have? All right, so let's look at K. That one looks real yucky, but remember, it's meant to push you out of your comfort zone. It doesn't mean it's more difficult just because it looks weird. So I get 2 times the cosine inverse of negative square root of 4x equals 5 pi thirds. Now, on this one, that x is under the square root. There's another question on one of these where the x is not under the square root. It's very clear when it's typed. make sure when you write it, you are clear to yourself where it is so you don't mess up on your own. Does that make sense to you? All right. So now I need to take care of this cosine thing, but before I do that, I have to get rid of this 2, which means that I want to divide by 2, but instead I'm going to think of it as multiplying both sides by 1/2 so that those cancel each other out, and I'm left with the cosine inverse of negative square root of 4x equals 5 pi 6. Everybody with me? So now, to undo a cosine inverse, that's cosine, right? So I'm going to take the cosine of both sides. The cosine of the cosine inverse takes care of itself. So I'm left with negative square root of 4x. And that's equal to, all right, so what's the cosine of pi 6? Square root of 3 over 2. And 5 pi 6 is in which quadrant? Second. So that means that's negative square root of 3 over 2, right? Everybody with me? Still got to know your values. All right, so now I could divide both sides by a -1, but I don't need to, because to get rid of the square root, I need to square it. It's going to take care of the negatives and everything on its own, so it doesn't really matter. But to get rid of the square root, so I'm going to square both sides. When I square the left, I'm going to get 4x. When I square the right, when I square the square root of 3, I get 3. Square 2, I get 4. I'm squaring it, not taking the square. What, squaring to? Yeah, I don't know what I said, but I meant to say squaring. There's no telling what came out of my mouth. I'm squaring them, yes. Everybody good? All right. Then I need to get 4 away from x. So yes, I'm dividing, but we're going to think of it as multiplying by 1/4 so we don't do weird things. These take care of each other, and I get x equals 3/16. And do you see how that's not like a crazy looking answer, but 3/16 seemed a little random, so I was like, but you know, it is what it is. What questions do we have? Anything? Do you see how you do have the skills for that, but you can't get inside of your, and if you're running out of time, maybe you run out of time, but take a deep breath and try and do things correctly. And if you don't get to the last part, you don't get to the last part. Like, it is what it is, but that's better than you trying to rush and nothing being right. Think about it that way too. All right, so then on C, so that was 4 points so far. So remember on C, so let's say we do have like a minute or 2 left and you're like, you know what, I don't even have time. There's no way I can finish this in the next minute or anything. And remember, it doesn't matter what that says. That could be hieroglyphics, okay? It don't matter. But if I want my input values to yield an output value of 2, I take whatever this nonsense is. So that is 3 sine squared x plus cosine squared x minus sine x. Ooh, I left off my x. X minus sine x. And I set it equal to 2. And that could possibly be a point depending on the question. You don't know. And then if you still have time left, don't give up. Because again, just because something looks crazy doesn't mean it wouldn't actually just work out very quickly and you didn't even realize it, right? Because you don't always know what's happening here. Now this one's not going to end up real quick. And I will tell you, you don't really have a lot of room, and I apologize for that. So you might want to write a little smaller. I didn't think to remind anybody, or you might have to go up the side or put an arrow, but it is what it is. I'm sorry. Okay, so we've got some squareds here. It is possible to have a quadratic with trig, but I have sine and cosine mixed. That's actually okay too sometimes, but that's usually because they're being multiplied and you can factor one of them away from it. So I would really like to replace this if I could. All right. So I know my Pythagorean identity, like I should know my Pythagorean identities, right? So I know that sine squared theta plus cosine squared theta equals 1. Right? And then I highly, highly, highly encourage you to write down what it is that you want so that we don't get the SIGNs mixed up sometimes. I want to replace cosine. So if I take this, I would make that cosine squared theta equals 1 minus sine squared theta. So now the cosine squared, I can replace with that right there. And that's what I'm going to do over here, right? So I've got 3 sine squared x plus. Now I'm about to substitute in something with more than one term, so I open my parentheses. Instead of cosine squared, I'm going to have 1 minus sine squared. And then minus sine x equals 2. Everybody with me so far? All right, so now I'm going to clean this up a little bit. Now you could do it all in one step, but I don't want to completely lose anybody, so I'm going to take more than one step for this. Do these parentheses, are they really doing anything? No, but you don't know that at the beginning necessarily, so we put them in there and then we go, you know what, I can just completely ignore them. So I've got 3 sine squared x minus sine squared x. That leaves me with 2 sine squared x. And then plus 1 minus sine x equals 2. So yes, this has trig in it, but yes, it is also a quadratic. Everybody agree with that? So I'm going to set it equal to 0 and rearrange things in the right order. So this gives me 2 sine squared x minus sine x. Then I have this positive 1. When I subtract the 2, that'll give me minus 1 equals 0. Okay. Now, do you see how it's just like a quadratic, but instead of x, we have sine of x? That is the only difference. All right. We've been factoring for a long time. This is why we have to be good at it and not stress us out, because then we throw this stuff in it. It looks yuckier, but it doesn't make it any more difficult. A is not 1, and that stinks, because when A is 1, it definitely makes everything easier. A is not 1, I'm going to need to do grouping. So 2 times a negative 1 is a negative 2. So I need 2 numbers that multiply to give me a negative 2, combine to give me a negative 1. So I'm thinking negative 2 and 1, right? So this is going to give me 2 sine squared x minus 2 sine x plus sine x minus 1 equals 0. Everybody with me? So I just broke up that middle term. I add these 2 back together, I get this. Okay, we're just splitting it up to do grouping. So now I'm going to group those 2 together, and I think I'll move over here. I can factor out of that a 2 sine x. That leaves me with sine x minus 1. Out of these 2, I can factor out a 1, and that leaves me with sine x minus 1 equals 0. So now I have 2 sine x plus 1 times sine x minus 1 equals 0. Any questions about where anything came from? You see how it's just factoring. And again, a couple of these steps, maybe I could have skipped, but I didn't want to lose you, and maybe it's best that we don't skip steps, right? Okay, so now that I have it factored, I can use my 0 product property. This gives me sine of x equals negative 1/2, and sine of x equals 1. All right. Now, sometimes these questions ask me for my answers on an interval from 0 to 2 pi. This one doesn't. It says all of them, which means that it's going to have a k thing in it. But I'm just going to go ahead and figure out what my values are first. So sine of x equals negative 1/2. Sine is negative here and here. The angle that gives me a sine value of 1/2 is pi 6. So that will be 7 pi 6 and 11 pi 6. And then the angle that gives me a sine value of 1 is pi halves. Now on this one, I'm pretty sure you wouldn't have gotten a point for this, but we don't know that when we start. And even just because it's trig doesn't mean that wouldn't be true, because their grading stuff can change. I'm pretty sure the way these points would lay out, just by the things I've seen, is you'd get a point for having these 3 correct, even though we're not done and it's not the real answer. And then your other answer comes, or your other point comes from the exact answer, which is 7 pi 6 plus 2 pi k, because it's 2 pi because it's sine, right? And then 11 pi 6 plus 2 pi k, and pi halves plus 2 pi k. All right. What questions do you have? Anything? All right. Now, again, I chose this one because it had a few challenging ones on there. They're not all challenging, so don't shut down on FRQ4, okay? Because we're going to do one more that I know you're not going to like, and then we'll end on a really easy one so you can see that there really are simple ones. And it's possible all 5 pieces could be simple. Who knows, right? So let's go to F. Find F. F. It has the 8s at the top right here. But then we're going to go all the way to the bottom. And we're going to do C. We're going to start here. Okay, so we have a function. We want our output to be this value, so that means I take my function and set it equal to that. So that's what we're going to write down. Cosine of x plus pi thirds minus the sine of x plus pi sixths equals 3/2. Right? So this is the sum identity. We're starting with Cosette, right? When Cosette's in charge, cosine x, she sits in the front with her sister, cosine of pi thirds. She tells everybody their signs are not the same, so this is minus. And she makes Sinbad, sine of x, sit in the back with his brother. So all of that green stuff came from the cosine part at the beginning. Okay, that's Cosette's deal. Then Sinbad's in charge. Now I've got that minus there first, so I need a minus. I know that's going to be more than one term, so I need parentheses. That's huge. Okay. Well, when Sinbad's in charge, Sinbad says Cosette's going to sit up front with him. And he's telling everybody their signs are the same. Then he has her sister sit in the back with his brother. And all of that nonsense should equal 3/2. Do you understand how to use their love story? Did I do something wrong? Or you have a question? Yes. Because all of the green is coming from here. So it's the cosine of the first one times the cosine of the second one. Okay, does that make sense? Okay, good question. Anything else? All right, everybody understand where everything came from? This looks horrific, but it's going to get better pretty quick here. We're going to evaluate what we can. So here, I mean, cosine of x is cosine of x. But the cosine of pi thirds is 1/2, right? So this can become 1/2 cosine of x. Minus, and then I can take here the sine of pi thirds is the square root of 3/2. So that's minus square root of 3/2 times the sine of x. Everybody with me? I'm just evaluating the part I can evaluate. Then I have negative sine x times cosine of pi 6. All right, cosine of pi 6, square root of 3/2. So minus square root of 3/2 times the sine of x. And then minus again, because I have to distribute that. Sine of pi 6 is 1/2 times the cosine of x, and that all equals 3/2. Okay, so I evaluated what I could. Some of it still had variables, but they're all the same variables. Things are looking a little bit better. Okay, we good so far? Look, I got 1/2 cosine x and a negative 1/2 cosine x. Those zero out. I have one and then I took it away. Then I have square root of 3/2 minus square root of 3/2. So that's a half of each. 2 halves make a whole. So that's negative square root of 3 times the sine of x. And that equals 3/2. So it condensed down kind of nicely, right? Any questions about what happened to anything or where anything is coming from? Okay. Now I need to get sine of x by itself, so I'm going to multiply by 1 over negative square root of 3. So those cancel each other out. Here, this ends up giving me square root of 3 No, it doesn't. That's a 3. Sorry, making stuff up now. 3 over negative 2 square roots of 3. I need to rationalize this to make it make sense to myself. So I need to multiply that by the square root of 3 over the square root of 3. I multiply straight across, and that's going to give me 3 square roots of 3 over negative 6, because the square root of 3 times the square root of 3 is 3 times 2 is 6. And then this reduces to the square root of 3 over 2, but it's negative. So that means what I actually ended up with here is that the sine of x is equal to negative square root of 3 over 2. What questions you got? All right. Now, this also says all the input stuff, so I'm going to have a plus pi k thing going on here. Sine is negative in these two quadrants. What angle gives me a sine value of the square root of 3 over 2? Pi thirds. So that means I need my third quadrant pi thirds angle, so that's going to be 4 pi thirds, and then I'm going to put plus 2 pi k, and then 5 pi thirds. Very good. Plus 2 pi k. Don't give up. And remember, I'm doing the weirder ones with you so you've seen them. They're not all weird. They're not all crazy difficult. Okay? What questions do you have? Anything? All right, we're going to stay on F. I'm going to go back up to the top here. And we are going to do this one. Okay? We're going to start with this one. So we're going to take h of x, and it's got to be equal to 2. So that's log base 4 of x plus log base 4 of 5 equals 2. Right? I don't even have any exponents I have to deal with, right? I'm adding 2 logs with the same base. So this is going to become log base 4. What do I do with the arguments? Multiply them. Of 5x equals 2. Everybody good so far? Then what do I do next? Change it to an exponential, yeah. So I'm going to do 4 to the second power equals 5x. So that is 16 equals 5x. So x equals 16 over 5. That's an algebra 2 question, right? But do you see how they're not necessarily all going to be crazy? So I don't want you to like have a bad feeling about FRQ4. I just wanted to make sure that we went through some of the more challenging ones, okay? But let's go ahead and let's do the one right above this as well. Because this one looks worse, but it's really, again, it's really not that bad. You just don't freak out. So I have 8 to the x power times 8 to the 2x power over 8 to the 5th, and that's got to equal 1. It's also best not to do too many steps in one, even though, yeah, it's okay to skip steps. You don't have to show every single step. Sometimes it's better, like baby steps to get through it so we're not making stuff up or we don't miss something. All right, so I would like to combine all this into one base of 8, but I'm going to start with the numerator here. So when I multiply these two, what do I actually do with the exponents? Add them. So this is going to be 8 to the 3x power over 8 to the 5th, and that's equal to 1. When I divide, what do I do with the exponents? Subtract them. So this is going to be 8 to the 3x minus 5 power, and that's equal to 1. Any questions at this point? All right, I need to get the variable out of the exponent. So that means I need to use a log. What do I want the base of my log to be? 8. So log base 8 of both sides, log base 8. And so this gets to come out front, right? So that's going to leave me with 3x minus 5. Log base 8 of 8 is 1. And that's equal to log base 8 of 1. That is something we can do, and I cannot leave that like that. I want you to think about, show you to draw little pictures and say, think about the parent functions all the time. Your parent function for an exponential looks like this. Your parent function for a log looks like this. Something you've known about exponentials forever is, first of all, how they look, plus 0, 1 is always a point, right? For the parent function anyway. Because you take the, anything to the 0 power is going to give you 1. Well, when you do the inverse, guess what? This becomes 1. So when my input is 1, what is my output? 0. So log, I don't care what base it is. You take the log of 1, any base, this becomes 0. You with me on that? And then, so then I'm going to add 5, so I get 3x equals 5, and x equals 5/3. Okay, we good on that? What questions do you have? Okay, it is up to you. Like, I have the keys for all of those made. Tomorrow we're moving on to FRQ1. We can work through more of these together if we need to on the Saturday or on the Monday, or, you know, whatever. You can come to tutorials. And also don't forget that you've got that student.desmos, those multiple choice questions. It's still important for you to be going through those as well. All right, we good? All right, we're going to stop here today.